Today, we're tackling a super common FEA headache, those crazy stress results from external loads. Ever get a result that looks kinda impossible? Like this, with stress just completely off the charts? So, what's going on? Is the software broken? Nope. The problem is how we're setting things up. It really just boils down to your external loads. So let's break down the three basic types. You've got forces, pressures, and torques, basically how the real world pushes and pulls on your part. But check this out. See that singularity risk? Forces are a huge red flag for causing these errors. So yeah, let's dive into the force load, because it's where a ton of engineers get tripped up. That trop has a name, a stress singularity. And get this, it's not real. It's a math problem. And the why is actually super simple. You already know this formula. Stress is just force over area. So, what happens when you put a force on a single point? A spot with literally zero area. Well, you're telling the software to divide by zero. And what do you get? Infinite stress. And that means your result will never, ever converge, no matter how much you refine the mesh. Okay, so how do we fix this? We need to be realistic. Let's look at a much safer bet. Pressure. See how this works? Pressure is always spread out over an area, which is how things work in reality. Next up, we have torques, another great realistic load, but it comes with a big gotcha. This is one of the biggest mistakes people make. You can't just apply a moment to a solid face. Instead, you've got to use an equivalent load, like a force couple, or your software's remote load feature. So it's not just about the load type. Getting the direction wrong can be an absolute disaster. This is especially true with buckling. One wrong move with a compressive load, and you get, well, this. The number you're looking for here is the buckling load factor, or BLF. It's your factor of safety. If your BLF is over 1, you're stable, but a negative value, that points to a major setup error. A negative BLF literally means your load is on backwards. The part will only fail if you reverse it. So here's the bottom line. For buckling, load direction isn't just important, it is everything. All right, let's wrap this up. Here's a quick checklist so you can absolutely nail it every single time. Now that you can spot these traps, your analyses are going to be so much better. What will you do differently?